In today's video, I would like to share with you a very nice problem of Serbian Mathematical Olympiad edition 2007. Here is the following information. Determine all pairs of natural numbers x and n. Here is the following equation. We have x cubed plus 2 times x plus 1 equals 2 to the n. Okay. So the thing that I have observed from this equation, the left hand side of this equation is involving x as a variable. So the right hand side of this equation is involving n as an exponent. This is a very nice problem, but there is a lot of tricks on the way to your solution. Okay. Now I'm going to give you some hints in order to solve this problem. So the first hint, you are going to check the obvious cases. The second hint, check the parity. The third hint, factorization. So the factorization in this case is playing a bigger role here. So it's necessary to go through the factorization in order to get the roots or to get something else. Okay. So the fourth hint that I'm trying to give, we are going to apply the Fermi Theorem. Fermi Theorem says if you have p as a prime and as an integer such that p not divide n, this implies n to the p minus 1 is congruent to 1 mod p. Okay, this is the fourth hint that I have. So if you would like to give it a try to this problem, go ahead, pause this video. When you worry, come back to see the full solution. Okay, let's get into the solution now. Now we are going to check the obvious case. The first case, if x equal to 0. Okay, x equal to 0, I'm going to replace 0 into this equation. I will get 0 here, 0 here. I get 1 equals 2 to the 0, which equals 2 to the n. Now I found the first solution, x equal to 0 and n equal to 0 as well. Okay, so it's very simple. So I'm going to go to check n equal to 1. Okay, so I will get here equals 2 to the 1. I'm going to bring this one to the right hand side of this equation. I will get x. Same time I'm going to take the x as a common factor. I will have x is multiplied by x squared plus number 2 equals 2 minus 1 equals to 1. Okay, since the product of these two terms equal to 1, this is impossible because this is bigger than 1. Okay, this is strictly superior than 1. It's impossible to have the product of this one equal to 1. Okay, that's mean there is no solution. No solution. Let's check the next case. Let's check n equal to 2. Okay, instead to start with n equal to 2, I'm going to check x equal to 1 is better, because if you check n equal to 2, you will have a crazy factorization here. It will be easier to check x equal to 1. If x equal to 1, we will have 1 plus 2 plus 1. This one is giving me 4, which equals 2 to the 2 equals 2 to the n. This implies n equal to 2. Okay, so we'll have another solution of x equal to 1 and n equal to 2. Okay, now we are moving on to the general case. Okay, because we are dealing with the n exponent as x is growing up and n is growing up as well. So far we don't know what the solutions are. Okay, so let's start with the general case when we have n strictly superior than 2. Before I start solving this one, I'm going to check the parity first. Okay, I have x cubed plus 2 times x plus number 1 equals 2 to the n. Okay, I'm going to move over number 1 to the right hand side of this equation. I will get here minus 1. Okay, this term is odd. Okay, that's mean the left hand side of this equation must be odd as well. Okay, odd. Then I'm going to factor out these two terms. I will have x is multiplied by x squared plus 2 equals 2 to the n minus 1. Okay, since the right hand side of this equation is odd and the left hand side of this equation is odd as well, so we have the product of these two terms. So that's mean odd is multiplied by odd is always giving you odd. That's mean x is odd and this term is odd, because this term and this term are having the same parity, and the product of two odd numbers is giving you always odd. It's mean odd. That means x is odd. That's the important thing. Now I know x is odd. Okay, let's continue proceeding with solution. as we have n is strictly superior than 2 in this case, that means x must be bigger than 1 as well, because as we grown up with n, x will be grown up as well. Okay, so this one is telling us x equals to 1 plus another natural number p. Where is a p? Is a some natural numbers, not include 0. Okay, I'm going to insert this fact into the original equation to see what's given us. I have p plus 1 cubed plus 2 times p plus 1 plus number 1 is giving us 2 to the n. Okay, now I'm going to do the things together by choosing n is an even in this case. Okay, if n is an even, that's mean there is another, that's mean n equal to 2m, where is m is strictly superior than 1 and n is strictly superior than 2. Okay, so I'm going to replace this term with 2 to m. Okay, so now I'm going to use the trick here in order to factor this one out. If you take a look at these two terms, this one is written on the form quadratic binomial, but is missing just p plus 1 quantity square. So we are going to add that term and subtract the same term at the same time. So I will have p plus 1 cubed minus p plus 1 quantity square plus p plus 1 quantity square. So as I did nothing, I just add this one, subtract this one. Okay, so plus 2p plus 1 plus number 1 equals 2 to the m. Okay, now I'm going to take these two terms separately by taking p plus 1 square, by taking p plus 1 quantity square as a common factor. I will have p plus 1 quantity square is multiplied by p plus 1 minus number 1, because this one is multiplied by p plus 1, this one is multiplied by number 1. Okay, by minus 1. So this one is a form quadratic binomial. It will be written on this form: p plus 1 quantity square. If you distribute this one, it's giving you p plus 1 quantity square plus 2 times p plus 1 plus number 1. Okay, then I'm going to take this term and move it over to the right hand side of this equation. Okay, so I will get, by simplifying this one, is 1 minus 1 is giving us 0. This one become p is multiplied by p plus 1 quantity square equals 2 to the m minus this term, which is p plus 1 plus 1 plus 1, which is plus 2. Okay, quantity square here. This is factorable polynomial, so I'm going to factor this one out. I will have 2 to the m minus p plus 2 factor 2 to the m plus p plus 2. Okay, so very nice. Here I will have a nice expression here by solving this equation by putting equal to 0. Okay, by finding the roots. So we'll have these following roots: 2 to the m equals p plus 2, and also I have 2 to the m equals to minus p plus 2. This is impossible because we have 2 to the m is a positive number. So I'm going to check this one. I have also p equals to 0 and p plus 1 equals to 0, implies p equals to minus 1. First table, we have chosen p as a natural number. This is impossible. This one must be bigger than 0. And also we have the negative solution, which is impossible as well. That means a contradiction. It is a contradiction. Okay, that means we have no solutions. No solutions when we have n is an even, n strictly superior than 2. Okay, now let's move on to check next case. When we have n is an odd, n is superior or equal to 3. Previously we found only two solutions, x equal to 0 and n equal to 0, and next solution was x equal to 1 and n equal to 2. So in the next case, when we have n is strictly superior than, when we have n is strictly superior than n is even, we have no solution as well. So I'm going to check when we have n is superior or equal to 3 is an odd number. Okay, suppose n is an odd for n is superior or equal to 3 and x is strictly superior than 1. Okay, So let's set x equals to alpha plus number 1, where is the alpha is a sum natural numbers, okay, not include 0. As I did before, I'm going to insert this value of x into the original equation to see what's giving us. So I have alpha plus 1 cubed plus 2 times is multiplied by alpha plus 1 plus number 1 equals 2 to the n, okay. As we said before, we have n is a odd. Let's set n equals to m plus 1. M is super equal to 1 and n is super equal to 3, okay. So now what I'm going to do now, I'm going to replace n with m. I'm going to replace n with 2m plus 1, okay. Now n becomes odd number. So what I'm going to do now, so this one is giving us 2 is multiplied by 2 to the m, okay. Now by using the congruence definition, so as we have 2 to the m is a congruent to minus 1 to the m. So as we know, this number is even because we have this one is even. So this one is giving us is congruent to 1 mod 3. So I have reduced the expression to mod 3, okay. I'm going through with that. This formula is true for mod 3 because when we have even here m is super equal to 2, this one is given us at least 4. When we take number 1 to the left side, you get 4 minus 1 is 3. That means 3 divides 3, okay. So whatever m is with this one is even, m is super equal to 1, always this formula is true, okay. So if you have this one odd, you have minus 1 here. When you take the minus 1 to the left hand side of this equation with the n is odd, for example, with the exponent is odd, is giving you 2 plus 1 3. You will have factorial polynomial. You will have 2 plus 1 is equal to 3. That means 3 is divide 3 as well, okay. So what I'm going to do now, I'm going to multiply both sides by number 2, okay. By multiplying number 2 here, this one becomes 2 here. So this one equals to this one. So I'm going to replace this one with its value. I will have alpha plus 1 cubed plus 2 is multiplied by alpha plus 1 plus number 1 is a congruent to this one, 2 mod 3, okay. I'm going to take this number 1 to the right side and make alpha plus 1 as a common factor for the left side, okay. So we'll have alpha plus 1 here, factor alpha plus 1 quantity square plus number 2. This one is gonna go here, it becomes 1, 2 minus 1 mod 3, okay. I'm going to simplify this one more. I will have alpha plus 1 factor alpha square plus 2 times alpha plus number 1 here plus number 2, which is 3, equals is a congruent to 1 mod 3, okay. Here is a nice expression involving congruence, okay. This product is a congruent to 1 mod 3. 3 not divide this product, that means 3 not divide both terms, because if 3 divides at least one term, you wouldn't have 1 here, you would have 0, okay. Starting as 3 not divide alpha plus 1 and 3 not divide alpha square plus 2 alpha plus number 3, okay. In the other word, GCD of 3 and alpha plus 1 equals to GCD of 3 alpha square plus 2 alpha plus 3 equals to 1, okay. What do you know about if 3 is not divide alpha plus 1, 3 is a prime. Now we are allowed to apply the Fermi Theorem here, okay. So by Fermi Theorem, we have 3 not divide alpha plus 1 implies alpha plus 1 as an integer square, because we have p minus 1, 3 minus 1 is a congruent to 1 mod 3. This is for one side. The other side, I will have The same thing here, same thing for the other term. I have 3 not divide alpha square plus 2 alpha plus 3 implies alpha square plus 2 alpha plus 3 square is a congruent to 1 mod 3. Okay, so what I'm going to do now, by taking off this exponent, I will have alpha plus 1 is a congruent to 1 mod 3. Number 1, it will be cancelled out from both sides. I will have 0 here. Okay, this one is telling us 3 divide alpha. Okay, I will have the same thing here. By taking off this exponent, I will have alpha square plus 2 alpha plus 3 is a congruent to 1 mod 3. Okay, but this one is telling us 3 not divide this term because you have 1 here. 3 not divide alpha square plus 2 alpha plus 3. Okay, this is very nice. So on the other hand, I'm going to work on this one now. Since we figure out 3 divide alpha is equivalent, alpha is a congruent to 0 mod 3. Okay, so that's mean alpha square is a congruent to 0 mod 3. That's mean alpha square plus 2 alpha is a congruent to 0 mod 3 by adding two terms together. Now what I'm going to do now, I'm going to just add number 3 on both sides. I will have alpha square plus 2 alpha plus number 3 is a congruent to 3 mod 3. Okay, as we know, 3 mod 3 is 0 here, so it becomes 0 here. It's telling us the same term, 3 divide alpha square plus 2 alpha plus 3. Okay, so you have two things here. I have 3 not divide alpha square plus 2 alpha plus number 3, and the same time I have 3 divides alpha square plus 2 alpha plus 3. How come 3 not divide this term in the same time 3 divides this term? Which is impossible. What we did here, we consider we have a solution when we have x is strictly superior than 1 with n is a odd. Okay, then we found no solution because of this contradiction. Okay, the only solutions that we found, only two solutions when we have x is inferior or equal to 1. Okay, I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.